Today, our group will present our project titled Smart Parking Space Detector. This system is especially designed to help drivers find available parking spots more efficiently. This presentation will be delivered by our team member Muhammad Danis Haikal, Abdul Naufal Fitri, Mika Johan, and Nurul Alfahmi. Moving on to the problem background, finding an available parking space in the common challenge in the busy location like shopping mall and hospital. This issue increases the traffic congestion, fuel consumption, and the carbon emission. While existing sensor-based parking system can help, they involve high hardware and maintenance costs. Therefore, this project proposes a cost-efficient, smart parking space detection system using a MATLAB and the image processing technique. For our methodology, the system operates in six sequence steps. Step 1 is a image acquisition, where we load the reference image, the test image, and the parking space coordinate. Step Step 2 involves image processing, which convert both images to grayscale and resize them to ensure identical dimension. In step 3, parking space attraction, the system crop each individual the parking area based on the predefined coordinate. Step 4 is the background difference analysis. Here the system compare each parking space against the reference image by calculate the pixel difference. Step 5, parking space clarification. Determine the status by the comparing the difference to the threshold value. If the difference is the greater than the threshold, it classified as occupied. Otherwise, it is empty. The final step is result visualization, which display the last parking status using the color bounding box alongside the total cost of occupied and the empty space.
Assalamualaikum warahmatullahi wabarakatuh. And now I will explain about the flowchart. So the process begins by loading the reference image, test image, and the parking space coordinates. Next, both images are converted to grayscale and resized to ensure they have the same dimension for accurate comparison. The system then extracts each parking space based on the predefined coordinates. For every parking space, the corresponding region in the test image is compared with the same region in the reference image by calculating the average pixel difference. The calculated difference is compared with a threshold value. If the difference is greater than the threshold, the parking space is classified as occupied. Otherwise, it is classified as empty. And finally, the system displays the detection results by drawing red boxes around occupied parking spaces and green boxes around vacant parking spaces. It is also shows the total number of occupied and available parking spaces. Next, we move on to the program codes. There are several image processing technique that we are using. First of all, pre-processing in this section converts both RGB image into grayscale to simplify image processing. It is also resize the test image to ensure both images have identical dimensions before comparison. Next, the parking space extraction and background difference. The system extracts each parking space from both images and calculates the average pixel difference. A larger difference indicates that a vehicle is present in the parking space. Next line codes is parking space classification. The calculated pixel difference is compared with the threshold value. The parking space is classified as either occupied or empty. And last but not least is display result. The detection result is visualized by drawing a colored bounding box. Red indicates Red indicates an occupied parking space, while green indicates an empty parking space. I think that's all from me. Thank you.
So this is the output of our system. The output shows that the system successfully detects the occupancy status of each parking space by comparing the test image with the reference image. Occupied parking spaces are highlighted with red boundary boxes, while available parking spaces are highlighted with green boundary boxes. In addition, the system displays the total number of occupied and vacant parking spaces, making it easier for users to monitor parking availability. In conclusion, we are very proud of our system because this project successfully developed a smart parking space detection system using MATLAB to identify occupied and vacant parking spaces. We learned how to apply image processing techniques, including grayscale conversion and background difference analysis. The system is simple and cost effective, but performs the best under consistent lighting conditions and a fixed camera position. Overall, the project demonstrates that image processing can be used as an effective solution for parking occupancy detection.
Welcome and hello peeps. So today my name is Mikael Johan bin Jeffrey Johan. Today I will be presenting to you all about our project entitled Parking Detection System. Okay, so before we start with the main, we have to run this code, which is the setup grid. This is where we will define, or let's say how to say define our parking space. So we have to select an empty space, an empty image from the CCTV maybe. Oh my god, what is going on? Where is the, hold on. Okay, all right. Okay, so here, first of all, as you can see, we have to click and then we do like a square to define how big we want the detector to be. So we click enter. So I suggest using a small one because you know sometimes there might be cars here that might be a big car that cover this square. So we need a very small square. Try to make a small square, and then we click where we want to put it. Let's say I put it here, and then we click enter, and then we do the same for the rest of the parking. Okay, I will put here. You know, see, okay. You might notice the numbering is quite off because we had to use ChatGPT to empty this parking lot. So yeah, it's very hard to find a data set that consists of empty parking spot. Okay, after we finish this, we need to click escape to save it. Okay, then we hopefully I can go back to my, okay, after we run that, as you can see here, it will save the data, and we can run our main. So we have to select which image we want to use. Let's say I use this one, and it will show which part is occupied, as you can see here, and there's the empty one. At the same time, we also output the result. Okay, so let's try with another image, if I may. Okay, oh sorry, my laptop is kind of slow. Okay, let's run again. Let's select another one, or I like this one. Okay, yeah, so basically how it works essentially is it checks whether this box has a different color than the empty one. So it's, you can see the red one, so we know that there is a car here. It's a Ferrari. Okay, just for the sake of it, let's try to run another one. Let's try this one, and there, of course, it will show which part is occupied and which part is empty. So yeah, and it also shows how much is occupied. So that's basically all about our system. Okay, thank you.